Assalamualaikum and salam sejahtera. This video is the first topic of the Code CSC 583 Artificial Intelligence Algorithms. In this particular video, we'll be introduced to artificial intelligence itself. So let's start. AI technology has improved tremendously. The pictures here show some recent remarkable invention. The first picture shows a Go match between Google's AlphaGo program with the master of Go. Go is a game more complicated than chess and thought to be a game that requires human insights and experience, one that cannot be learned by computers. However, AlphaGo defeated all human masters of Go. The second pictures shows a self-driving car. It is a car that navigates using multiple radars and sensors on board its body. Third picture shows an application that can translate in real time. You can actually try this feature by downloading Google Translate on your smartphone. And finally, the final picture shows a Boston Dynamics robot. Instead of stiff movements we usually associate with robots, this one can run, jump, somersault, and do many acrobatic moves. Human technology has gone through many revolutions. In the first revolution, humans start to mechanize water and steam power. Machines using steam were introduced, lowering the reliance on human labor. In the second revolution, mass production, assembly line, and electricity makes efficient factories that are capable of producing high-quality products quickly with lesser mistakes. The third revolution, meanwhile, introduces automation and computers. Machines can automatically and safely produce products and components in factories. Lesser number of human workers need to be employed, just some machine operators. And now we are in the fourth industrial revolution. We have cyber physical systems. These are machines that are online and are intelligent enough to know what to do based on inputs from other connected machines. We are now in Industrial Revolution 4.0. Some remarkable innovations include AI, industrial internet, industrial cloud computing, industrial big data, robot 3D printing, knowledge work automation, industrial network security, virtual reality, and many more. These are the objectives of this video. The first to understand what exactly is AI and what are intelligent machines. And then we'll talk a little bit about Turing imitation game. We'll discuss the 4 machine learning methods. We will talk a little bit about what is the programming paradigm of AI and list out some of the state-of-the-art AI. The first person that introduced the term artificial intelligence is John McCarthy, where in 1956 he organized a workshop in Dartmouth College. The results of this workshop was Logic Theories, which is a computer program developed by Newell, Simon and Shaw, and it is the first program deliberately engineered to imitate human problem-solving skill, the first AI program. When talking about artificial intelligence, there are some discussions we want to discuss. Can machines think? And if so, how? And if not, why not? And what does this say about human beings? And finally, what does this say about the mind? The two big questions pondered by philosophers for over 2,000 years are, how does the human mind work? And then, can non-humans have minds? These are still unanswered. Before we talk about artificial intelligence, we must first understand intelligence itself. Intelligence is the ability to think, learn and understand instead of doing things by instinct or automatically. This is the definition provided by the English Dictionary, Collins, London, 1990. To think, humans need to have a brain or an organ that enables learning and understanding so that we can solve problems and make decisions. Therefore, we can define intelligence as the ability to learn and understand, to solve problems, and to make decisions. So these are the 4 keywords we need to remember: to learn, to understand, so that we can solve problems and make decisions. We have defined intelligence. We have extracted the 4 keywords: to learn, to understand, so that we can solve problems and make decisions. So now let's look at definitions of artificial intelligence. Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like human, and it has the ability to, yes, again, the 4 important concepts: the ability to learn, to understand, to solve problems, and to make decisions. There are, of course, other definitions of artificial intelligence too. Here are some from Kurzweil, Richard Knight, Shalkov, Luger and Stubblefield. So you can read on definition as presented by these scholars. Still, in other definitions of artificial intelligence, scientists have also proposed the 4 paradigms in which AI can be viewed. Is it a system that thinks like humans? Or is it a system that thinks rationally? Is it a system that acts like humans? Or is it a system that acts rationally? So these are the 4 paradigms in which we can view artificial intelligence. Now, what exactly is the goal of AI? So the goal of AI is to make machines do things that will require intelligence if done by humans. Therefore, we need to answer the questions. Can machines think? The answer is actually not a simple yes or no. Alan Turing, a very remarkable computer scientist, asked these questions about AI. Is there thought without experience? Is there mind without communication? Is there language without living? And finally, is there intelligence without life? These are all variations of the same question: can machines think? When we ponder about humans who are blessed with intelligence, we notice that some people are smarter in some ways than others. Some are good at music, some good at sports, some good at math, some can write beautiful stories. We can also make very intelligent decisions, but sometimes we also make very silly mistakes. For example, you might have calculated, budgeted, and carefully bought a car, and then you forget where you put the car keys. Humans all have capabilities to learn, understand, solve problems, and make decisions. However, our abilities are not equal and different. Therefore, if machines can think, we must expect that some machines might be smarter than others in some ways. For example, Waze is better at finding paths, but Netflix is better at recommending movies. AI is prevalent in our life. Here are some examples on how AI is used in many fields. In the post office, we have automatic address recognition and sorting of mail. In banks, we have automatic check readers, signature verification system, automated loan application classification. In customer service, we have automatic voice recognition. While in the web, it can identify your age, gender, location from your web surfing. It can also have automated fraud detection. Digital cameras now have the capability to automatically tech and focus faces, while computer games can have intelligent characters and agents. Intelligent beings are capable of doing this, perceiving, recognizing, and understanding the real world, reasoning and planning about the external world, learning and adapting. So, what are principles we should follow to achieve these capabilities in machines? Alan Turing, in his wisdom, decided to avoid semantic arguments about machine intelligence. He instead decided to create a thought experiment called Turing Imitation Game or Turing Test. Let's discuss the Turing Test. There are two phases. In the first phase, we have an interrogator, a man, and a woman. They are all in separate rooms. Both man and woman communicate with the interrogator via text. The man will try to deceive the interrogator by convincing that he is the woman, while the woman must also convince the interrogator that she is a woman. Now, the interrogator must decide which participant is the woman. Meanwhile, in the second phase, the man has been replaced by a computer program. This computer inherits the same mission as the man. It must also convince the interrogator that it is the woman. It will also try to make human-like mistakes to fool the interrogator. If the computer can fool the interrogator that it is the woman, it is said to have passed the intelligent behavior test. The computer program wins the Turing imitation game. The Turing test has two remarkable qualities that make it really universal. First, by maintaining communication between the human and the machine via text, the test gives us an objective standard view on intelligence. This means intelligence has nothing to do with how you look, how you sound like, your gender, race or religion, any outward factors. Second, the test itself is very versatile. It can be conducted in two phases or only a single phase. It can also be used in any field, and we focus on the content or the performance of the machine. For example, if we are using Turing test on a self-driving car, the car must perform as good as a human driver. It is Alan Turing's belief that before the year 2000, there would be a computer program that passed the Turing test. While this has not been achieved, Turing test has successfully provides the basis for the verification and validation of knowledge-based systems. Just like a human can't be an expert in many fields, programs are usually intelligent in a specific field only, and its performance will be measured by comparing it with the performance of a human expert. For example, an intelligent cooking robot will be measured against its performance versus Gordon Ramsay. Since 1991, a Turing test contest has been contested called the Loebner Prize. In 2019, the chatbot Mitsuku won the competition for the fourth time in a row. If you are interested in trying to chat with Mitsuku, you can actually Google this chatbot. We talked previously how we are in the fourth industrial revolution. Artificial intelligence is one of the keys contributing to this revolution. For example, AI allow machines to operate autonomously on tasks that previously must be completed by humans. Autonomous things exist across 5 types: robotics, vehicles, drones, appliances, and agents. Here are some examples of autonomous things. We have an autonomous food delivery robot, autonomous drone in agriculture, an autonomous or self-driving car, and autonomous home appliances. Another remarkable achievement of artificial intelligence is Internet of Things, and specifically here we are discussing Internet of Bodies. Internet of Bodies are basically body-attached, implantable and embedded devices that interact with sensors in the environment. However, with the introduction of IoB, there are concerns on the security, privacy, physical harm, and abuse on humans. Here are some examples of IoB. Smart contact lenses that are able to monitor glucose levels, artificial lenses that are used to correct vision, Bluetooth-equipped electronic pills, and digital tattoos. Now, let's talk about social credit algorithms. It is a type of algorithms that uses facial recognitions and other biometrics data to identify citizens. A very well-known system is the one implemented in China. The social credit system in China is a national reputation system where you can be rewarded or punished based on your behavior. For example, if you are considered to be untrustworthy, you might be banned from traveling overseas. Other fields of AI in technology are virtual reality and augmented reality. What differentiates between VR and AR is VR is more immersive. You will be wearing a headset to experience the program, while AR layers the virtual components on top of the real scene using our smart devices. In our syllabus, we'll be learning how intelligent programs are trained. There are 4 methods. The first one is Artificial Neural Network, or ANN. This is a training method that imitates how the human brain works. The second one is evolutionary computation. It imitates the theory of evolution. The third one is fuzzy logic. It imitates human uncertainty. So for example, my definition of hot might not be the same as your definition of hot. And the fourth method that we'll learn throughout our syllabus is swarm intelligence. It is a training method that imitates the behaviors of bees, ants, fishes, and other animals that move in swarms. Next, let's talk about the programming paradigm of AI. A programming paradigm is the way or the style of computer programming, the way that we build the structure and elements of computer programs. The programming paradigm of AI is called logic and symbolic programming paradigm. It uses declarative approach by establishing facts, making queries, and reaching conclusion using deduction. A logical program is divided into 3 sections. The first one is called domain, which is a series of definitions or declarations that define the problem. The second one is called facts, which is a statement of relevant facts. And the third one is statement of goals in the form of a query. This is an example of a programming done using Prolog, which is a programming language used in logic or in AI field. So this is an example of a Prolog program in a Prolog console. Now let's talk about state-of-the-art AI. So state-of-the-art means the most remarkable innovation. So when we're talking about state-of-the-art AI, what is the latest and most remarkable achievement that is in the AI field? What can AI do today? So a concise or a simple answer is difficult because there are so many activities in so many subfields, but we can take a look at some of the examples. So in game playing, Deep Blue, which is a supercomputer by IBM, managed to defeat the world chess champion Garry Kasparov. So this was in 1997. So it was quite a long time ago. Next, in the field of natural language understanding, computer programs are capable of understanding meaning behind words and how words are combined to form meaningful sentences. It is capable of doing this to the extent that IBM's Watson, which is another supercomputer, was capable of playing and winning a TV game show called Jeopardy against human competitors. Next, in the robotic fields, there are so many robots that have been invented and developed. One of the most famous robot is called Asimo Honda. So you can actually read more about this robot by going to this website. So again, in the field of robotics, scientists have developed a type of robot capable of showing emotion. So it is called Kismet. So if you look at these pictures, this robot uses eyebrows and lips to show some emotions such as angry, surprised, sad, interested, or happy. In machine vision, AI technology has achieved lots of capabilities. So the one being shown here is face and facial recognition. So I'm sure all of us are familiar with this technology. Like in Facebook, if you upload a certain pictures, it can actually ask you whether you want to tag someone because it is capable of detecting or recognizing who is the one inside the pictures that you have taken and uploaded. So as a conclusion in this video, we have first discussed about the definition of artificial intelligence. We talk about what does it mean to be an intelligent system. So we said that a system is intelligent in a narrow field, and to check the performance of this intelligent system, we compare it with a human expert in that particular field. We have also discussed the Turing imitation game or Turing test, which is an experiment in 2 phases. And then we discussed the 4 machine learning methods. It was ANN, volitionary algorithm, fuzzy logic, and swarm intelligence. We have also talked a little bit about programming paradigm of AI. And finally, we discussed some of the states of the art of our current AI technology.